We'll proceed in mind-blowing, solving tedious calculus problems. Tedious calculus problem that we are trying to solve. We will take more example, but right now we have concentrated in 4 dimension, calculating the weight of a sphere. If I have density of a sphere, that is x square plus y square plus z square plus 3, then what is the weight of a sphere where the radius is a? I have a sphere and radius is a. Okay, if I have a sphere and radius is a, then what is the weight of the sphere? What is the volume of the sphere is 4 pi a to the power 3 by 3. That is the volume of a sphere whose radius is a. Okay, in that scenario, what would be the weight of a sphere if radius is a and density is capital D? Straightforward, right? Capital D into volume is the net weight. If D is dependent upon volume, as per the algebraic fundamental, if I am trying to multiply two items, one is independent and one is dependent. Anyway, multiplying two items, there are two ways to calculate the multiplication. If I want to calculate multiplication of two items, okay, if I want multiplication of 3 into 5, one way is add 5 three times. This is what we do. 3 into 5 means 15. Okay, multiplication is nothing. It's a repeated addition only. 3 into 5 is 5 plus 5 plus 5, 3 times. Okay, what is another way you were talking calculating the multiplication? Calculating multiplication has two way to calculate multiplication. One is repeated addition, 5 plus 5 plus 5. Or take a rectangle and one side is 5, another side is 3. And take a square whose width and height is 1. Now place inside the rectangle. The square, that is area, is 1, height is 1, width is 1. Place inside the rectangle. When it is packed, now count it, how many they are. That is also a way to calculate the multiplication. Calculating the area doesn't mean that I am going to multiply width into height. Not required. Just take 1 by 1 square and place inside the rectangle and count it. This is actual way of calculating the area, not the multiplication. That is the actual way of the calculating the area. Okay, so if two way we calculate the multiplication, calculus goes with the second way, because second way is perpetual, calculating the multiplication through calculation of the area. Their dependency and independency also work. Like if I have width as x, okay, and height as also x, where height is dependent upon width. Many times I have given this example. If this width is x-axis and height is x, the height at every point is x. If x is 0, height is 0. When x is 5, height is 5. X is 2, height is 2. Like this. Then it will form a triangle. So multiplication of x into x, where one x is independent and one x is dependent, then x into x will be x square by 2. How you know it? I drew a graph and I came to know it is a triangle. Half of the rectangle is the area. So x square half is x square by 2. Similarly, for any height into width, where height is dependent upon width, then multiply height into width can be calculated through calculating the area. So it is h into width or h into d of width, because we are calculating the multiplication through the area calculation, not directly. So we place d over there. Calculating the, but you are talking about integral calculus. This is integral calculus. Integral calculus means calculating multiplication through area. That's it. The way it looks like calculus and integral calculus, differential calculus. Integral calculus means calculating multiplication of two items, while one item is x-axis and one item is y-axis, calculating the graph and then underneath the graph what is the area. That is the two way of calculating the multiplication. One is direct, one is repeated addition. What is x into x? Both are independent to each other. Then it is x square. I did x, added x time x square. What is x into x when both are independent to each other? X axis, y axis. X axis, both are independent to each other. It will form a rectangle. But if one is dependent upon another, then it will form a triangle. So two way of calculating the multiple. One is repeated addition and one is by calculating the area. In calculation of the area, we can think about dependency and independence. Whereas repeated addition, it is only possible when both are independent to each other. Calculating the multiplication of two items, calculating multiplication of two operand when one is dependent upon another through the area way is integral calculus. That's it. Okay. What is integration of x along what axis? Along x axis. X into x. But we are saying integration means we have to calculate x into x through calculation of the area. So right hand side x is independent component. There we place d, claiming this is independent part and this is dependent part. It is also called dependent part as integrand and independent part as differential in calculus. Now this is x axis and this is origin. This is y axis. If this is a graph, then if I say I'm calculating the area and the area comes in form of algebra only, and if I set x to some value, then area will be from 0 to that point. I can calculate area between x1 and x2 also. Okay, that is 0 to x2 area minus 0 to x1 area. That is the net area. That is the net area. So net integration is called integration sign, snake sign, limit x1 to x2. Integrand, that is dependent component, d of independent component. It is also called differential. Anyway, this is the basic concept. We are calculating weight of a volume. If we are calculating weight of a volume, then it is we have density capital D into D of V, means it will go through area way to calculate the multiplication. That is integral calculus. Anyway, we have not done through Cartesian, but it can be done through Cartesian. We have done it through a spherical coordinate system. Then we did through three-dimensional Jacobian. Density is x square plus y square plus z square plus 3 into d of volume or d of xyz cube. That is similar to d of xyz cube by d of theta r phi cube into d of theta r phi cube. D of xyz cube by d of theta r phi cube. This is nothing but if there are two components, one is theta r phi and one is xyz cubical axis, then xyz is dependent upon theta r phi through some relationship. D of xyz by d of theta r phi means if there is in theta r phi, if there is 1 unit of volume change, then it will bring how many? If I make 1 unit of volume, there is a volume on theta r phi, cubical volume, whatever it is. From there, if I make 1 unit of change, then whatever the volume in the xyz, how many unit of change I see, that is d of xyz cube by d of r theta phi, whatever comes into d theta dr d phi, and then density I have to specify r theta phi. We are going through method of substitution, and then volume v1 to v2. Now I have to segregate it to theta from 1 to 1, phi from lower to higher, and r from lower to higher. Okay, anyway, we have done it. The question is arising that if person is not able to understand three dimension Jacobian, if someone remembers, we did P1 cross P2 cross P2 whole dot product with P3 divided by delta theta, delta r, delta phi. This was the net d xyz cube by d theta r phi. Anyone would say, what we are trying now, dxyz cube, right? D of volume, that is d of xyz cube. This is what we are trying, right? Can't we do in two dimension Jacobian? Can't we do? So this is the topic for the today. Can we solve three-dimensional Jacobian, three-dimension integration, that is d of xyz cube? Altogether it is four dimension. Three dimension d of xyz, d of xyz cube. Can I solve this in two dimension Jacobian? Rather than saying d of xyz, can we make something like only two dimension Jacobian? I can take xy, or I can take yz, or I can take xz together. One I can keep outside. Okay, can I solve a single dimension Jacobian? Not required. These are not available in any of the book. That can we solve 4D problem or 3D Jacobian with 2D Jacobian? Is it really possible? Okay, let's see it through microscope or binocular. What is difference between microscope and binocular? Okay, anyway. So let's see through it through microscope. Anyway, our channel name is Meaning, and its a kind of logo is miniature science. So we will see through miniature science. So what is the net? What are we trying to calculate net here? Net, we are trying to calculate density, that is x square plus y square plus z square plus 3 into d of volume, limit is volume 1 to volume 2. This limit is three dimension, where if I break it into three parts, then it will be z equal to minus square root of a square minus x square minus y square to square root of a square minus x square minus y square. Y equal to minus square root of a square minus x square up till square root of a square minus x square. X is minus a to a. How this became, please watch previous two videos, that how we a certain limit. Okay, the main problem is in four dimension, where density is a function over any x comma y comma z coordinate. If I take any coordinate x comma y comma z, then density is variable with the x comma y comma z. X comma y comma z, altogether we took a independent variable called volume. There is nothing like a volume. But when we go through calculus, we try to find two items. One is dependent, one is independent, irrespective of number of coordinate, number of dimension that we are addressing. We are addressing here four dimensions, but we are interested only in two dimensions. One dimension is density, and another dimension is volume. So limit is volume 1 to volume 2. I can break the limit in z1 to z2 and xy plane 1 to xy plane 2. Again I break xy plane into y1 to y2, x1 to x2. This is what we did. If we have to find the weight of a sphere, then the biggest dependent component in the weight of a sphere is z-axis. Okay, here volume is independent and density is dependent, but volume itself is a sphere. And as far we see the Cartesian coordinate system, then z, that is height of the sphere, is variable with x and y. Height is not a flat line the way it happens in cubical region. So cube is the default 3D shape of Cartesian coordinate, where each side of the cube is parallel to the coordinate axis. So there are three sides in the cube. One is xy plane, or there are three planes. One is xy plane, and that is parallel to x-axis and y-axis. One is yz plane, one is xz plane. They are parallel to the xyz axis, but sphere is not parallel to any of the axes. Then the default coordinate system of the sphere is spherical coordinate system, where the radius coordinate, and theta coordinate and phi coordinate, they are along the shape of the sphere. But a sphere is not the default coordinates, is not default shape for the Cartesian coordinate system. So their z is variable with xy plane. That's why we say z equal to minus a square root of a square minus x square minus y square, because the equation of the sphere is x square plus y square plus z square equal to a square. In that sense, z equal to plus minus square root of a square minus x square minus y square. So z is minus a square root of a square minus x square minus y square up till square root of a square minus x square minus y square. Now here xy plane 1 to xy plane 2 that we broke. Anyway, now if I break xy plane 1 to 2, then the sphere, if I take, there is a sphere. Okay, so there is a sphere. Okay, so there is a sphere. There is a sphere and it is centered at the origin. There is a sphere and it is centered at the origin. If that is the case, this is xy plane. Cut it at the half. Top hemisphere above the xy plane and bottom hemisphere below the xy plane. And if that is the case, then we have z is minus square root of a square minus x square minus y square to square root of a square minus x square minus y square. Now, what about xy plane? If xy plane cuts it at the center it will form a circle. If it forms a circle at the center, if it forms a circle at the center, then circle equation is x square plus y square equal to a square, where a is the radius of the sphere. In that sense, y equal to square root of a square minus x square. So xy plane, if I break in the limit, this is the class. There are three classes we see in the integral calculus. One is dependent component, that is integrand. One is differential component, that is independent component, and then limit. All three are very big things. Now y is minus a square root of a square minus x square to square root of a square minus x square. X is minus a to a. Okay, if there is a circle, if there is a circle on xy plane, x and y are again related to each other, unfortunately, where the curve of the circle is not parallel to x-axis or y-axis. Again, problem is there. They should be parallel to the x-axis, y-axis. Like if I take a square or rectangle, then the sides of rectangle or square are parallel to x and y-axis. They are de facto shape in Cartesian coordinate system. But circle is not the de facto. Circle is de facto shape in the polar coordinate system. Okay, there we can have the limit as constant, not dependent upon each other. But here, since it is a circle, y will be dependent upon x. So y is minus a square root of a square minus x square to a square root of a square minus x square. And then x is minus a to a finally. Anyway, now idea is, can I solve it? The integrand is x square plus y square plus z square plus 3. And then we have d of x, y, z cube, d of volume. Can we solve it with dual two-dimension Jacobian? Okay, that is the question. Now here, if we try to solve it, consider this is dxyz cube. I can break it into dx, dy, dz also. Which one I have to tackle first? X, y or z? First we have to tackle z, because z in the limit is dependent upon x and y. Then we have to tackle dy. Then we have to tackle dx, dz, dy, dx. We have to tackle one by one. And then this is how we have to tackle the limit. Okay, I believe it is understandable. So if I try to solve in 2D Jacobian, then I have to take yz as 2D. Dx we will solve later. If I say y and z, if this is the sphere, then this is x-axis, this is y-axis, and this is z-axis. YZ means YZ plane we are talking. If I cut it in YZ plane, I get a circle. If I cut in Y, this is not available in any of the books. Solving it through two-dimensional Jacobian. Amazing, mind-blowing. So if I cut it into YZ plane, then it will make a circle in YZ plane. The equation of the circle. Now I can now take parameter. I can take some method of substitution as per the integration. Y equal to r cos theta, z equal to r sin theta, because it is a circle. So this substitution makes sense. If that is the case, then what is dyz? Now we have dx, d of yz, d of volume. I broke it into d of xyz cube. Again, I broke into dx into d of xy plane. I can break it. Because first I have to take it from the right side. This is what I saw through the limit. So right side z and y I can take first. D of yz. This is a research solution, $1 trillion solution. D of yz plane. Where now d of yz. Now if I break into Jacobian, the d of yz plane is same as d of yz by d of r theta into d of r theta. Now it will become like dp by d theta cross dp by dr in same fashion. D theta dr dp. P is a position vector in Cartesian coordinate system. Now we have d of x I plus yj by d theta cross d of xi plus yj by dr. I'm sorry, d of yi or d of yj plus zk divided by d theta cross d of yj plus zk divided by dr. Now first will become d of r cos theta j plus r sin theta k by d of theta cross d of r cos theta j plus r sin theta k by d of r. If someone breaks it, then it will become r minus sin theta j plus r cos theta k cross product, then cos theta j plus sin theta k. If someone settle it down, it becomes r cos square theta plus sin square theta. It becomes r at the end r. So now we have dx r dr d theta. Okay, now here we have integrand at x square plus y square plus z square plus 3. Now it turns into x square plus y square plus z square becomes r square plus 3. R. Multiply it becomes x square r plus r to the power 3 plus 3r dx r d theta dr. Now limit is z minus y minus x minus a to a, whatever limit it was. Okay, now it will be long calculation, big calculation. I am not supposed to do this much. I can try, but this much. What is the shortcut I can take without altering to the approach what we are doing? We'll take density as 1. If I take density as 1, then the net dxyz cube net integration will give the volume of the sphere if I take density as 1. What I'm trying to say is dx r dr d theta. No one would have heard this term. Dx density is 1 into dx r dr d theta. Now triple integration will give the volume of the sphere because density I have taken constant 1. This is to validate that our approach is correct or not. If we try like this, then dx I can keep just at the end r dr d theta. R dr becomes r square by 2. D theta becomes theta. Okay, now we have z equal to y equal to r cos theta, z equal to r sin theta, y square plus z square equal to r square. So we have r square by 2. I can transform it back into y square plus z square by 2. Okay, dr is gone, integration is done. D theta integration is theta. Now we have z equal to y r sin theta. y equal to r cos theta, z by r equal to tan theta, theta equal to tan inverse z by y. Now we solved it so quickly. The integration is y square plus z square by 2 into tan inverse y by z dx. Okay, dx is remained. Now we have the limit. So first we will settle down the z limit. Z limit is minus square root of a square minus x square minus y square to a square root of a square minus x square minus y square. I can take it into 2 into 0 to a square root of a square minus x square minus y square. 2 I multiply it because it is a sphere, so it will be congruent in z. It will be congruent in y also. Y rather than minus square root of a square minus x square. So square root of a square minus x square, I can say 2 into 0 to a square root of a square minus x square. So 4 I can keep outside. X is minus a to a, y is 0 to a square root of a square minus x square. Z is 0 to a square root of a square minus x square minus y square. And now we have y square plus z square by 2 tan inverse z by y dx. Okay, now let's solve for z. So z upper limit is square root of a square minus x square minus y square. So y square plus z square will settle down in a square minus x square by 2. A square minus x square by 2. By 2 was anyway there. Outside 4 we have kept it. Okay, tan inverse z by y. Z, okay, that is the first. So z is square root of a square minus x square minus y square by y, tan inverse. That is the upper limit. If I take lower limit, then we have x square plus z square plus y square by 2. Z is 0 in the lower limit. Here z by y 0. Tan inverse 0 means 0. Full gone. So only upper limit will, that's why I have taken 0. So upper limit will come only into the picture. Okay, if that is the case, then we have anyway, if someone had taken lower limit also as minus, it will come as double one. Anyway, now it is a square minus x square by 2 tan inverse square root of a square minus x square minus y square by y. Now y limit we will take 0 to a square root of a square minus x square. So a square minus x square by 2 remain and tan inverse will work here. Okay, tan inverse a square minus x square minus y square by y. If y is 0, if y is a square root of a square minus x square, that is the higher limit, then the numerator becomes 0. If numerator becomes 0, tan inverse 0 means 0. Okay, then full will become 0. Okay, so this full becomes 0. Anyway, what about when y equal to 0? If y equal to 0, the denominator of tan inverse is 0. Infinite, tan inverse infinite is pi by 2, 90 degrees. Okay, so pi by 2 I can keep outside. Now outside we have 4 into pi by 2. Now here we have a square minus x square. A square minus x square by 2 dx. Makes sense? Now a square minus x square by 2 integration with dx. 2 I can keep outside. Pi by 2 by 2, 4. Pi by 4 into 4. 4 gone. Pi remains outside. Now we have integration of a square minus x square dx. That will resolve into a square into x minus x to the power 3 by 3. If I set minus a to the power minus a to a minus a to a, if I keep a first one, top one, then it becomes a to the power 3 minus a to the power 3 by 3. Since it is power is a kind of odd number, so I can take 0 to a multiply by 2. I can take that way also. So now we have outside 2 pi and then 0 to a. Then it becomes a cube minus a to the power 3 by 3. It becomes 2a cube minus a cube by 2. I am sorry, 3a cube minus a cube by 3. 3. It becomes now 2a cube by 3. It becomes 2a cube by 3. That is the volume. Outside we have 2 pi. 4 pi a cube by 3 is the volume of a sphere, and it is exactly all right. We can solve it through two-dimensional Jacobian also. Mind blowing. This is something that is not available in any of the book. You can try. Now anyone is free in similar fashion to calculate the net weight, where density is x square plus y square plus z square plus 3. So dx r dr d theta, that was the initial. R becomes, R will multiply inside here, and it becomes r x square plus y square plus z square equal to r square. That is r to the power 3 plus 3r dr d theta. Then it becomes r square by 2x square plus r to the power 3 by 3. X square plus y square become r square. R to the power 3 by 3 plus 3r square by 2. Okay, now someone has to return it back r as a square root of y square minus z square back, and then set the z limit and y limit, and then d theta will become theta tan inverse z by y. Whatever it comes, then integrate with the x. I'll try doing it and see if it is same as what we calculated through a spherical coordinate system and three-dimension Jacobian. Then this would validate our approach. Mind blowing, amazing. We will take more examples. Okay, and we will see how three part, that is integrand, differential, and limit, how they how they we change it if we are making it some method by substitution. So that we will see. Amazing, mind blowing. Why don't you support us? Please don't mind supporting us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code.